Today we're looking at a HL function question that's asking us to find the largest value of a such that f has an inverse function. When we're taking an inverse function, we're flipping the function in the domains. So we're flipping in the y equals x axis, meaning if we have like a simple parabola like this, we are rotating around this line and we would get something like this. Now, in this case, the inverse function would not exist for a basic y equals x squared parabola because it would fail a vertical line test and it would not be a function. That's effectively what we're being asked about here, is you can always go through the process of trying to come up with an inverse function, but the inverse function doesn't exist because it can't be a function when you invert it. A good way to test for this is we're going to have something that fails a vertical line test when it inverts if the original function fails a horizontal line test, because you're just flipping the domain and the range. So when we look at a function like this and we see that it fails a vertical line test when we draw a horizontal line, it fails a horizontal line test when we draw a horizontal line through like this, we're really looking to set a domain that will stop that from happening. And to do that, we need to basically stop here at the turning point. It says here that x is less than or equal to a. So what we want to do is we want to keep the rest of the function, which is going to be all of this part I'm highlighting in red, up to this point. And so long as we go only up to this point and we never turn the corner, we're not going to, when we invert, we're not going to have any problems. What this does mean then is we need to figure out where the local minimum is on our graph, which is why we're going to differentiate it. So we're going to take this function, f of x, e to the 2x, minus 4 e to the x plus 2. The derivative is going to be 2 e to the 2x minus 4 e to the x, and then the 2 disappears. This is our derivative. We're going to be at a minimum where this is equivalent to 0. And then this is fairly tricky to solve, but when we're looking at this, when you've got a 2x in here, that's effectively, you could think about it like it's e to the x squared. So we can actually factor e to the x out of this like it's a quadratic. I'll take a 2 out as well since we can. And this is going to leave us with e to the x minus 2. So two possible ways we can solve this. It's like a basic factoring problem. 0 is either equal to e to the x, which is not possible because e is basically 2.71. There's no power I can raise 2.71 to that's going to make it a 0. Alternatively, we can have this, which would give us e to the x equals 2. And then if we think about this as a logarithmic problem, that means that x would be equal to ln 2. Basically, I'm applying ln to both sides of the equation, and I'm using the logarithmic power rule to move the x out in front. Or you can think about this is just a straightforward rearranging of a logarithm, re-representing this relationship in logarithm form. So the answer here is going to be ln of 2. And then it says, for this value of alpha, or a, figure out an expression for the inverse stating its domain. Okay, so when we're thinking about stating the domain of an inverse, one thing I'm going to keep in my mind is we're supposed to be flipping around the x and the y values when we take an inverse. So my domain of my inverse function really ought to be the equivalent of my range for my original function. So if we think about the original function here, our range was, it looks like, greater than or equal to 2. So I'm going to carry that with me to represent the domain of the function that we're going to get. Now, let's focus on how we can invert this. So to take the inverse of a function, we are going to swap the x and the y values. So this is going to become x equals e to the 2y minus 4 e to the y plus 2. And we've got to focus now on finding ways to kind of rearrange this so that we have y as our subject, ideally. So I guess obvious first step, move this over, and then we've got e 2y minus 4ey. Now, this is a little bit of a tricky situation because I've got y and e to the y in multiple places, which I really don't love. And I think we're going to have to be a little bit creative in finding a way to isolate y. So one of the things I'm thinking of kind of carrying on with this idea that e to the 2x or e to the 2y is a bit like e to the y squared, maybe we could complete the square here so that we only have one e to the y available. So let's give that a go. So if we've got e to the y minus 2y, I would be thinking about representing this as e y minus 2 squared. Now we would be missing on the end of this a plus 4, which we never had at the beginning, right? So I added in effectively a plus 4 when I turned this into e to y minus 2 squared, right? I've basically fabricated a 4 out of nowhere, so I'm going to need to add a minus 4 on the end here, which will then carry over, and we're going to have x plus 2 equals e to the y minus 2 squared. Now that we've got this in completing the square form, we've created this nice little package that we can square root both sides. So when we do that, we're going to get the plus or minus the square root of x plus 2. This is equivalent to e to the y minus 2. Now, this is a part where we have to be a little bit careful because we had a restriction with y. We said y, I think it was y needs to be less than or equal to ln 2. Now, if we think about how this affects what's set up here, if we've got e to the y, and we put ln 2 in the place of e to the y, that would make this equivalent to 2, right? But if this was anything smaller than ln 2, the value of e to the y is going to therefore be smaller than 2, and this entire right-hand side would be negative. So it's either 0 or it's negative, which means we need to preserve only the negative version of this left-hand side. Okay, and then we can rearrange this further, so we can go, I don't want this in red, we can go, let's do green, green is nice. We can do 2 minus root x plus 2 equals e to the y, and then I can just apply a logarithm to both sides. This becomes y, this becomes ln of 2 minus root x plus 2. When I apply a logarithm here, it just turns into y because I can always move the power out, so we would have basically y ln e, and then ln e is just 1. So this, if you apply a logarithm to both sides and you've got e to something, it just turns into that thing. Now, we need to think about our domain here. If you remember, we said that our domain was going to be basically our range from the previous problem, so we need to, or from the previous function, so we need to kind of preserve that relationship. So I know for sure that x is going to be greater than 2, and it looks like we were equal to 2 would be my guess, so greater than or equal to 2. And then additionally, I want to look for if there are any further restrictions that have been created when we're looking at the math we have here. So first off, I can't take the square root of a negative number. I can square root 0. I can't take the square root of a negative number. So am I in danger of that happening? Well, if we keep to this restriction of x being kind of greater than, oh, it was less than, was it greater than 2? Y is greater than or equal to 2 to negative 2, sorry. That's a bit of a mistake. Okay, so y needs to be greater than or equal to negative 2. Okay, well, I can square root of a 0, so negative 2 would be okay. If we had negative 1 or 0, that would be fine as well, because I'd still be square rooting a positive number. So this all seems like it's not creating any issues. But then I'm thinking in terms of 2 minus something. Well, another rule I'm worried about breaking here is that I can't take a natural logarithm of a negative number. So I need to make sure, in addition to this rule, that I'm also following a rule where this is greater than or equal to 0. I can't take a logarithm of 0 either, so it wouldn't be equal to, it would just be greater than. And then what we're going to do is just kind of play around with this. If I add that to the other side, I'm saying I want this to happen. Basically, what are we worried will happen here? I've got to keep my value on the right-hand side smaller than 2. Well, I'm worried if I put in anything bigger than 2, or even 2 itself, we're going to get 4. Square root of 4 is 2. So this is actually creating kind of an upper limit on my value for y, for x, sorry. So x is going to need to also be smaller than